All right, we're back. We're going to be on page 5 of note 16 of Calc C, talking about parametric equations. The top of this page really just gives kind of a slightly more formal, I guess, limit definition approach to finding dy dx. But we've already talked about how, via the chain rule, dy dx is actually just dy dt over dx dt, an abbreviated, really convenient way of writing that because there's all those dt's hanging around. It's y prime over x prime. So you can read through this if you want to. It's not bad. I mean, it's got the magic step that so many things have, where you multiply by a weird form of 1, right? Where you have 1 over h over 1 over h is just a strange form of 1, but you can do that, and then it like becomes the derivative. So that's basically it. And now here's the chain rule version. So this page has everything. All right, so when you're talking about the slope of a parametric curve, you're still talking dy dx. And so we're going to calculate it. We're going to use it. Let's see if we can do this problem. So given the parametric equations, so this is, what is it? This is not an ellipse. If it were sine of 2t, cosine of 2t, it would actually be a circle. This is a, I don't know how to pronounce it, Lissajous curve, something like that. They're the curves that are like, I don't know, they make like basket weaving or some terrible example. It's that basic idea though. So let's find dy dx. So I'm going to find first dy dt, because I think you should find that first, because what you do, most humans, is divide the first thing by the second thing, regardless of like what you should actually do. So here we can kind of hack through that by making sure the first thing we find is the one we need. dx dt will be 2 cosine of 2t. So we're finding dy dx. So combine these. Dy dx is -3 sine of 3t over 2 cosine of 2t. That in no way, shape, or form simplifies. Use your calculator to find the equations of the lines tangent to the curve at its x-intercepts. Then use your calculator again, then graph your curve. Cool, it's all calculator. All right, so at the x-intercepts, so x-intercepts, we're dealing with, so y has to equal 0, right? So cosine of 3t equals 0. Should I just be using my calculator for this? I mean, like, probably, but like that feels like cheating. So I'm gonna like keep going here. So 3t. So if t is between 0 and 2 pi, this is a good review. If t is between 0 and 2 pi, then 3t has to be between 0 and 6 pi. Get all those answers and then divide them by 3. So where's cosine equal to 0 on those intervals? So pi over 2, and then 3 pi over 2. And then, so 6 pi is going to be 12 pi over 2. So we'll keep counting by 4s, I guess. So, 5 pi over 2. I mean, I guess by 2 pi. Keep adding pi is what I'm not saying. There's a ton. Oh my God. 9, 11. So 12 pi over 2 would be 6 pi. So now this is, it's all the over 6s. 3 pi over, so pi over 2. 5 pi over 6, 7 pi over 6, 9 pi over 6. Oh, 9 pi over 6 is 3 pi over 2. And then 11 pi over 6. I believe that to be the collection of t values. And then the equation, man, we want the equation, okay. All right. So let's switch to a calculator, because that seems like a lot of work. And I mean, I should have done it to begin with, because it says to use a calculator. All right, x of t is sine of 2t. Y of t is cosine of 3t. So we can like find the derivative, right? Like let's do, ew, not the nth. Why is it on the nth derivative? All right, t of y of t over the derivative with respect to t of x of t. What's it going to tell us? I think it's going to be -3/2 sine of 3t secant of t. No, it usually does sines and cosines, so I think it'll give us what we got. And then if we wanted to, we could do solve x oh, y of t rather, equals 0 for t, but let's limit it 0 to 2 pi. So such that, and all the inequalities is control equals, gives you there. Press enter. So these are all the values that we found. Holy cow. Okay, well the y value is 0. So I need to evaluate the slope at like all of these. What should I'm gonna name this. Let's say dy dx of t, right? Dy dx, sure. Is that, all right, so dy dx of pi over 6. I think what's gonna happen is that a lot of them are the same. I don't actually know that that's gonna happen. Pi over 2, 5 pi over 6. Okay, so 5 pi over same slope there. So maybe 7 pi over 6 positive. I don't know what my goal is here. 3 pi over 2. And then 11 pi over 6. All right. So what am I doing? I also need like, you know what I should have done? I'm going to do, we're doing it again. I need to know the x coordinate. So I need x of t. I know that y is equal to 0. And then I need dy dx of t. Such that, can I just get all of them? Probably not. Pi over 6. All right, so I'm going to write that one in. So at pi over 6, we get, so the y, so it's y minus 0 equals the slope, which is -3, and then x minus radical 3 over 2. All right, and then we're rolling. So pi over 2. Is there like a lack of symmetry? No, there's not. Pi over 2. Y is going to be, the slope is -3/2, and then x minus 0. At 5 pi over 6. There aren't that many. There aren't that few, but 5 pi over 6. So it's going to be -3x plus radical 3 over 2. Not bad. Definitely running out of space though on where I'm handwriting. So that's not great. I moved them over a little. Gonna move some more stuff. It's like if you're working on an iPad, you almost never run out of space because you can just move things. If you're following the spacing I originally used though, you probably run out of space all the time. 7 pi over 6. You know, honestly, I gotta finish this video so I can get to class. I did not consider that when I set out on the journey of a million tangent lines. 7, 3 pi over 2, and then 11 pi over 6. God. And all I'm doing is like showing you the calculator too, so it's like not even that entertaining. 3 pi over 2. So 3/2 x. 3/2. Right, x minus 0 though. Not a duplicate. None of these are duplicates. And then 11 pi over 6. Y equals negative radical. Nope. Ah, crud. Am I flipping these? No, that's the first one that I messed up. I put like this, the x coordinate for the slope. I should have just done it like super generically. Plus radical 3 over 2. Okay. Let me just show you what I've handwritten. And then what I'm going to do is I'm going to like hardcore use the calculator to answer the next part so that I can get to class on time. It's my goal. It's a good goal, right? Get to class on time. Maybe at some point when you're watching this, you will have appreciated that I got to class on time. These are the tangent lines, I think. I'm pretty confident. So I'm going to go back to the calculator. So pause this if you want to copy them. But I'm going to go back to the calculator, and we're going all calculator all the time to get these, I think. Let's see if we can do that. Nope. Oh, we're on the calculator. What am I doing? All right. So I need to solve y of t, x of t equals 0 for x. For t, come on. For t. All right, I need to limit that between 0 and 2 pi. Actually, I should have included. Well, it didn't matter. What do I do here? This? Sure. Okay, so 2 pi is included. Oh, good. There's like not that many. Now I need y of t, x of y of t. X is definitely 0. So y of t, comma, dy dx of t, such that t equals pi over 2. All right, so what is it? X is equal to 0. X equals 0, no matter what. Oh, so these are horizontal. Horizontal tangent lines? Why am I so confused? These are not horizontal, that's the slope. All right, here we go. At t equals, holy cow, at t equals pi over 2, I get y minus, so minus 0 equals negative 3/2 x minus 0, because x is 0 all the time. Maybe if I wrote that, it would help. X of t equals 0. So x is equal to 0. All right, at t equals pi, just change this up to a pi. I'll just change this to a 1. Negative 1, 0. So the slope is 0, which means it's just the y value is negative 1. Y equals negative 1. I'm feeling less than great about this, but that's okay. That t equals 3 pi over 2. It's like I'm getting them, I think I'm getting them right, but like I'm really struggling to articulate this. So what you get, try to squeeze in some videos between classes, you know, gotta do it. Y minus 0 equals 3/2 x minus 0. I'm going with it, I think that's right. And then the last one is at 2 pi. So 0 would have been included also, I guess, because they're coterminal. At t equals 2 pi, I get y minus 1 equals 0 x minus 0, so just y equals 1. Ugh, gosh. If you take a look at the graph, let's do that. Graph, I got to graph parametrically. Menu 3, option 4, and then x of t, y of t. There you go. Now, I don't think I have the patience to try to put in all of the tangent lines. I mean, I definitely, we both know that I have the patience to do it. I just don't want to, really. Could I do like a super generic tangent line? Potentially? Let me try this. I'm gonna change back to function mode. And what do I want to do? I want to do, all right, so I want to do y of like z, I guess, plus dy dx of z, x minus x. I don't know what's going to happen there, x of z, because I named a function x. Classic mistake. Let me just see what happens if I do z equals pi over something. Pi over 6. Do you work? Do not work. Create a slider? Don't create a slider, so cancel. Okay, that worked. Here we go. Can I do this? I'm going to give it a list. Pi over 6, comma, pi over 2, comma, 5 pi over 6, comma, 7 pi over 6, comma, 3 pi over 2, comma, 11 pi over 6. Do your thing. And do not make sliders. Okay, that's not working. Why not? Those should like have moved. And I don't fully know why they did not. My thought is that it has something to do with this. It's like I should rename the function x as like something else and then go for that, which I can do. Let me try that. And then I like just don't know what I'm doing wrong. So x of t, I'm gonna make that like q of t, I guess. Answer. Oh, that's gonna mess up my derivative. Ah. Where did I ever define dy dx? Let's recall a definition. Menu 1, recall definition. Oh, Okay, so that actually has no impact on it because I didn't use the function. It's like values. So then del var x. I got to change some stuff. And then this still might not work. X, now you're Q of Z. And Z is certain values. Fixed it. Except, obviously, unintended consequences. If I go back, I have to change my parametric equation now to Q. There we go. So those are the tangents at the x-axis, looking good. And then on the y-axis, do I want to do the same thing? I guess. Am I going to run into the same problem? I guess. So I'm not going to do. Exercise left to the viewer. All right. See if you can modify it, get it to do it for the y values. I'm going to go back to the notes, show you what I got so far, and then call it quits on this video, which went longer than it should have because I messed up left and right, and I managed to confuse myself about a lot of things. But that's okay, because it happens. All right. So these, I think, are our answers. They kind of like make sense to me based on the graph that we were just looking at. Like 1 and -1 feel right for those, and so on. So yeah. All right. I'm going to call it a video on this one, and I will see you in the next one, which will probably be tomorrow or the next day, or who even knows. So see you then.